So sketch it out. We're going to plot exactly where this side is. So remember, we have our initial side is always going to be right here. And then plot this point, and we can connect the terminal side through it. So 12, negative 5, if we go by 2, 4, 6, 8, 10, 12, and then negative 2, 4, 6. So 12, negative 5 is like right there. And then we can connect the terminal side going from the origin through that point. Okay, so the angle that we're measuring is technically the angle that starts right here and goes all the way around the unit circle and then lands right here. So it's going to be a big angle. It's somewhere between 270 and 360. So what we do is we take this point, kind of drop it down, like almost make a little triangle out of it. So this guy in here would be our reference angle. We're going to call that theta prime. So we can treat it kind of like we treat normal triangles. Measure on the side length. So this is, we call that 12 because that's the x value. We're going to label this with a negative 5 because that's the y value. And then we can find this piece right here. So to find that piece, we do Pythagorean Theorem. So we would do 12 squared plus negative 5 squared equals r squared. So we call that r. We use x, y, and r when we were dealing with the 12-3 stuff. So 12 squared is 144 plus 25. Add those together, we get 169. And then square root to get r by itself, and that is 13. Okay, so we can label that on there as well. So this is the one we just found, was 13. Okay, so remember, this little guy in here, this whole thing, that's our actual theta. This little theta prime that I drew in here is the reference angle. So we can still use SOHCAHTOA with regards to that little angle. So we need sine, cosine, tangent, kind of the main three, SOHCAHTOA, and then we'll do our reciprocals. So sine, we defined it in this section to be the y value over r. So the y value is negative 5, and then r was 13. But you can still kind of do a SOHCAHTOA thing with it. If we look at this reference angle, you can still do opposite over hypotenuse, because when we drop down this line, this turns this into a little right triangle. So this would be the hypotenuse, this would be the opposite, and this would be the adjacent. Okay, very similarly, cosine, we defined it to be x over r. So the x coordinate is 12, and the r coordinate was 13. But again, you can still kind of think of it as adjacent over hypotenuse when you're looking at this little triangle in here. And tangent is the y coordinate divided by the x coordinate. But again, opposite over adjacent works just fine when you're looking at that triangle. All right, and then finally we do the other three. The other three we just flip. Okay, so that flips to the reciprocal. Secant is the reciprocal of cosine, and cotangent is the reciprocal of tangent. Okay, so that's what we're looking for with those, is your 6 trig functions. So you guys are going to have lots of practice with the 6 trig functions. Okay, number 10, a reference angle. Find the reference angle for 285. Okay, so whenever you're asked to find a reference angle, my recommendation would be to sketch it out. So 285, if we know kind of where our main angles are, we've got 0, 90, 180, 270, 360. So it's going to be somewhere in here. It's going to be way closer to the 270 than it is to the 360. All right, so this angle right here is approximately 285 degrees. What the reference angle is always the shortest distance back to the x-axis. So this is our x-axis right here. The reference angle is always the shortest distance back to the x-axis. So it's this measurement right here that we're looking for. So the way that we find it, this is 360 degrees, this is 285 degrees. We want to figure out what the difference between them would be. So what we do to find the reference angle is we subtract 360 minus 285. Okay, it's not always 360 minus 285. It's always supposed to be the shortest distance back to the x-axis. So if we were over here, we'd be subtracting with 180. It's just wherever you're closer to the x-axis. So 360 minus 285 leaves us with 75 degrees. Okay, so that means there's a 75 degree difference between this angle and the x-axis. So you're always taking your shortest distance back to the x-axis. All right, so that's 12.3. Next section we're going to be working on is 12.4. And now remember, as soon as we get into 12.4, we are no longer dealing with right triangles. They are not right triangles. It might pop up, I suppose, that you have one of your angles that's 90 degrees, but we're assuming in 12.4 and 12.5 that they are not going to be right triangles. All right, so in number 11, you were given triangle FGH, which is not a right triangle. G was equal to 80 degrees, H was equal to 40 degrees, and little g was equal to 14. And then you're told to solve the triangle. So when we solve the triangle, we find all the missing pieces. So the missing pieces, we have angle F, side F, and side H. Those are the pieces that are missing. So once we find those pieces, we will have solved the triangle. So this is the angle side case that we're going to use. First thing you can find, whenever you have two of the angles, it's always super easy to find the third angle. So we're going to start with that. So capital F, what we do is we know that all triangles add up to 180 degrees, so we're just going to subtract away the other two angles and see what we're left with. So 180 minus 80 is 100, minus 40 would leave us with 60 degrees. So that's angle F, and that's just kind of what was missing so that they could all add up to 180 degrees. So that part was easy. Next part, we're going to move into what we call the law of sines. Law of sines is the one that started with like sine A over A, sine B over B. So let me write just so you've got it on the screen. So sine A over A equals sine B over B equals sine C over C. We also saw a very similar rule where we just flipped the numerator and denominator. And so there are two different versions of this equation, and they make sense in different cases. So this one makes sense if you're looking for an angle, because the angles are the capital letters, and you want your variable that you're looking for to be in the numerator. And then same thing with these ones. If you're looking for a side, which are the lowercase letters, you use this version, because again, you want your value to be in the numerator. So what we're going to do, we are going to look for either little f or little h. It doesn't matter which one. We might as well look for little f because it's the one I wrote down first. So we're going to set up this version of the law of sines because we're looking for a side length. So it's going to get set up using this. If we have a pair, you're always going to set up one of the pieces using the pair. So we have little g over the sine of g. And it doesn't matter that these are a, b's, and c's, and these are f, g's, and h's. The process works the same. Equals, then we have little f over the sine of capital F. Okay, so we set that up. Once we solve for this, we're going to be able to get the f by itself. And so the way to get the f by itself is to multiply both sides by the sine of 60 degrees. So it'll cancel right here. And of course, to keep the balance, we've got to multiply by the exact same thing on the other side. So I'm going to show you what that looks like if we plug it in. So we have the sine of 60, and then times 14 over the sine of 80. Okay, so we just have that whole left-hand side that I have written down. We've got it plugged in, and we get this. So we get about 12.3. So f equals 12.3. So that's our first missing side. Now, people get really tempted to do Pythagorean Theorem here. You cannot do Pythagorean Theorem if it's not a right triangle, which means we can't do it here. So we're going to set up the same little ratio here, except we're going to look for h this time. So we're going to put little g over the sine of g, because that's the pair that we were given at the beginning, equals little h over the sine of h. Okay, so we're doing the exact same thing, just this time we're looking for a different variable. So I'm going to multiply both sides by sine of 40 in order to get little h by itself. This will cancel, and I multiply by the same thing over here. And I'm going to plug that into my calculator now. Okay, so we've got sine of 40 times 14 over the sine of 80. So just plugging in the exact thing I had on my paper. And I get about 9.1. Okay, so that was my last piece. I'm going to write it up here, 9.1, and that would be my final answer. So like I said, that's what it means to solve for the triangle, is to find all of the missing pieces. Okay, next one from 12.4 is number 12. We are given triangle ABC. A equals 34 degrees, little a equals 8, and b equals 13. This is one of those where I'm going to ask you if you have 0, 1, or 2 solutions, and then solve. Okay, so this is the side-side angle case. If you have the side-side angle case, this is the only situation in which you would have to check for 2 solutions. Okay, so only the side-side angle case, you would have to check for 2 solutions. So that's what we're going to do. Pay attention to what we're missing. First thing that we want to find is capital B. So we have a pair of A's, which means we can set up, using this right here. But then the first thing we want to solve for is capital B. So I'm going to set that up. So sine of A over little a equals sine of b over little b. Now, note the difference between these two ratios. I put this in the numerator this time because I was trying to solve for capital B. Whatever you're trying to solve for, you want it in the numerator. You can do it the other way, but it's always easier when your variable's in the numerator. All right, so we're going to try to get b by itself. First thing is going to be multiplying by 13. And 13 will cancel over here, and I'm going to plug in exactly what I have on the left-hand side here. Okay, so I'm going to get a decimal. When you're doing this decimal thing, because this isn't b yet, it's the sine of b, make sure you write down enough decimals, like 0.9087. Write all those down. And then this is the sine of b. So we saw a previous example just like this. If you're ever looking for the angle, but you don't have it yet, you always do inverse. So instead of sine, we're going to change it into sine inverse. And remember, when you turn into an inverse function, it flips the two pieces. So we changed sine into sine inverse, and these two pieces traded places. And when they traded places, angle B ended up by itself, which is what we were trying to do. So when you plug this in, grab your sine inverse button, and then you can just arrow up and just paste this so that you get all the decimals. So we get 65.3. Oops, 65.3. There we go. Okay, or this is the scenario, only the side-side angle, where we start looking for a second possibility, okay? And what we do is we envision sitting here at our 65-degree angle, and we know from looking at the unit circle that there would also be a value right over here that would have the exact same value of sine. So we know that sine of 65.3 is this value right here, but this point would also have that exact same sign. So we need to figure out what that angle is. So what we do is we subtract it from 180. Okay, so we say, or B could be 180 minus 65.3. Because this right here is your 180. This is your 65.3. If we subtract away 65.3, it'll land us at this angle. So we check this just to see if it's a possibility. So I'm going to do 180 minus 65.3, and that leaves me with 114.7. So we definitely know this one's going to work. The way we check to see if this one is going to work is to see if this angle B and this angle A could fit inside of a triangle. And if you look, 34 plus 114 is only 148. There's still plenty of room for another angle in there. So if there's still room for another angle after you do this, then this is also a distinct possibility as well. So now we're going to separate ourselves into these two different triangles. If these angles combine to be more than 180 degrees, this wouldn't be possible and we'd only have one triangle. But as it turns out, both of these angle B's could fit in with this angle A separately, not together. So we can now look for angle C's for both of these. So angle C, we know we start off with 180 degrees in the whole triangle. Subtract away angle A, subtract away angle B, and we'll see what we're left with here. We're left with 80.7. Okay, so for this triangle, triangle number 1, capital C is 80.7. Let's do the same thing over here. We know this angle C will be 180 minus angle A. Angle A is the same for both of them. And then minus this angle B. And we're left with 31.3 degrees. Same thing up here. Okay, so the last thing we're missing for both of these triangles is little c, and that's our side length. We're going to do the same thing that we did up here when we found side lengths using the law of sines. Okay, so we're going to start with the pair that we were given. We were given a pair of a's. So we're going to do little a over the sine of a equals little c over the sine of c. And so for this one, we use 80.7 as c. And then we can solve for little c by multiplying both sides by the sine of 80.7. So these will cancel, and I'm going to plug this in. Okay, so we get about 14.1. So that is little c. So this triangle is complete. You've got all three of the missing pieces. And then for our last step over here, we can do the exact same thing. So start with the pair. Little a over the sine of a equals little c, which is what we're trying to find, over the sine of this value of c, which is 31.3. Okay, so multiply both sides by this, and it'll cancel. And then we do the exact same thing over here. Okay, so this over here is going to get plugged into the calculator so that I can figure out what little c is. Oops. And 7.4 would be our other value of c. So now the second triangle is complete. All right, so that's your law of sines stuff. That's 12.4. This was the side-side angle case. The previous one that we started with was the angle-angle side case. So either one of those. If you have a pair, that's the important part. If you have a pair of anything, you're going to use the law of sines. Here we had a pair of g's. Here we had a pair of a's. So if you have a pair, you're starting off with the law of sines. If you don't, we're starting off with the law of cosines, and that's what you guys are looking at with 13 and 14. Okay, so number 13, we have little a, little b, and little c. So this is the side case. With the side case, we always start with the law of cosines, and the reason you know that is because you don't have any pairs. We have just one of the a's, one of the b's, one of the c's. So we know we're going to start with the law of cosines. In the side case, you have to make sure you're finding the biggest angle first. Okay, so let me write down law of cosines, just so you have these formulas. Okay, so they're essentially all the same formulas. You can see how similar they are. You just pick which one you're going to use based on which thing you're trying to find. So, like I said, we start with the biggest angle, which is going to be across from the biggest side. So the first one we need to find is capital C. So that means we're going to be using this version of the equation. So plug in everything that we've got. So c squared is 12 squared equals a squared plus b squared minus 2 times a times c times the cosine of c. I'm sorry, that was 2ab, I said c. So we're trying to get c by itself. First thing that I've reminded you guys of is that this is kind of one joint unit. That stuff stays together. Do not separate it out. So let's simplify everything else up. 12 squared is 144. 5 squared is 25 plus 8 squared minus, and this would be 2 times 5 is 10 times 8 is 80. So that 80 stays attached to the cosine of c. Do not add and subtract all these numbers together. Remember, order of operations, multiplication is stronger. So these add up to 89. I'm going to subtract 89 from both sides. All right, so I subtract 144 minus 89, and that leaves me with 55 equals negative 80 times the cosine of c, and now I can break away that 80 with division. Okay, so these cancel, and I'm left with this right here. I'm trying to find an angle. So remember, when you're trying to find an angle, you do the inverse thing. So we change this to inverse cosine, put this on the inside, and then we get c by itself. So when we change original cosine into inverse cosine, these two pieces will swap places. Now I'm going to get the c by itself. So let me plug this in. Inverse cosine of 55 divided by negative 80. That leaves me with 133.4 degrees. So very big angle for that first one. That's why we start with the biggest one first to make sure that we're getting the right angle and then working our way down. So now we have a pair. Now we have big C and little c. So as soon as we have a pair, we can set up law of sines to find the next one. So the next biggest one is going to be the 8. So we're solving for angle B first. So set up sine of C over little c equals the sine of b over little b. Okay, so we set that up. We're going to be solving for an angle this time, so we know we're going to be using inverse again. Start by multiplying both sides by 8, and I'm going to plug this whole thing in. Okay, so I keep this decimal and keep a whole bunch then, like 0.4844. Is equal to the sine of b. And remember, like I said, you do inverse if you're looking for an angle. So we switch this into sine inverse, plug the 0.4844 inside, and that means we have b by itself. So when you switch from sine into inverse sine, the two pieces trade places, and that's how we get b by itself. So I'm going to do inverse sine and just paste this value right in there. So I get this, about 28.97, so that would actually round just right up to 29 degrees. Okay, and then we take our leftovers. Our leftovers will be angle A. So angle A, we know that all three angles have to add up to 180 degrees. So when I subtract away C and subtract away B, I will be left with angle A. So I'm going to plug that in. Okay, that was 17.6 for angle A. Okay, so I found all three of my missing angles. The trick with that one is to make sure you start with the one that you know will be the biggest. All right, next one, 14, is also starting with law of cosines. We're solving this triangle. So I told you this with the previous one. The indication that you are using law of cosines first is because you don't have a pair yet. This is the side angle side case. It's two sides with the angle that's in between. So the first thing we're going to find is the last side. And we find the last side by using one of these formulas up here. So now since we're given angle B, we're going to use this version of the formula. All right, so we start with B squared, that's what we're solving for, equals A squared plus C squared minus 2 times A times C times the cosine of angle B. So this is all just numbers on the right-hand side. So you can just plug that whole thing into your calculator. So I'll show you what that looks like. So 6 squared plus 3 squared minus 2 times 6 times 3 times the cosine of 110. And you just plug that whole thing in. And we get this, 57 point, and then you can keep a bunch of the decimals. So 57.313. Okay, and then to get B by itself, we take the square root, like that. So I'm going to take the square root and then paste that whole answer in there, make sure I get an accurate value. So I get about 7.6. So B equals 7.6. So now I have a pair. I have both of the B's. And as soon as you have a pair, you can use the law of sines, just like we did in the previous problem. So let's find angle A first. So sine of angle A, which we don't know, over little a, equals the sine of angle B over little b. Okay, so we do that, we're going to be able to get angle A by itself. So start by multiplying both sides by 6. This will cancel out. And then I'm going to plug this right-hand side into the calculator. So I have the sine of 110 over 7.6 times 6. And it gives me this value. Remember, when I'm looking for an angle, I keep a bunch of those decimals, so about 0.7419. Okay, and if I'm looking for an angle, I have to write this as inverse sine, and then you swap those two pieces. And as soon as I plug this in, I will have my angle A. Like that. So about 47.9 is angle A. And finally, the last angle is always the easiest piece because you know that all of the angle measurements in a triangle add up to 180. So for angle C, we start with 180, subtract away angle B, subtract away angle A, and whatever that leaves us with, that is 22.1. So angle C is 22.1 degrees. So again, that's what it means to solve the triangle. You've got a whole bunch of missing pieces. Once you find them all, then you have solved the triangle. So that's 12.5. The stuff that we have on the back of the worksheet is 12.6. These functions, I don't want to try to redraw them, so I'm just going to go right off the sheet here. So this is the first thing you've got from 12.6 is finding the period of a function. So what I want you to do when you're trying to figure that out is almost talk yourself through what the pattern is doing. So if we start right here, 0, what the pattern does, it has a tall peak and then a short peak, and then a tall peak and then a short peak, and then a tall peak, and then we would assume that it starts a short peak. So each pattern goes like this, tall peak, short peak, and then it starts repeating. So if you figure out where it starts repeating, then you know when the first cycle ends. So right here is where it starts to repeat. It does tall peak, short peak, and then it starts to repeat after that point. So as soon as it starts repeating, that's the value of the period. It went from 0 to 4, then from 4 to 8, and then we would assume it would go from 8 to 12. So the length of the period is 4, how long it takes to get through one cycle. All right, next. This one's a little bit more complicated, but we can do the same thing and kind of talk ourselves through it. So we go to the right. We do a long rectangle up, a short rectangle down, go to the right, short or long rectangle up, short rectangle down, go to the right, long rectangle up, short rectangle down, go to the right. So it starts by going to the right. So after right, long rectangle, short rectangle, that's when the cycle ends. And then it starts to repeat itself again. So the value where it ends is 2 pi. So that means the value of the period would be 2 pi. All right, so I'm going to start copying down these last ones. We'll get through 16 and 17, and we'll be all done with this practice test. So number 16, we've got a point that's located on the unit circle. So remember, if you were on a unit circle, the x value is cosine, and the y value is sine. So we can use those values to find the 6 trig functions. So let's set these up. So we've got sine, cosine, tangent, start with the 3 main ones. So sine is just the y value. It is root 2 over 2, and that's just about as easy as it gets. And then same thing with cosine. It's just the x value, so we pull it right off that ordered pair. Tangent is the y value divided by the x value. Remember, tangent is supposed to be y divided by x. We don't want to divide fractions, though, so the way that we do divide fractions is by multiplying by the reciprocal. So I'm going to flip this to its reciprocal. So 2 over negative square root of 2. So if you look and see, everything's going to cancel. The only thing that's left behind is a negative, so we would technically have a negative 1 as our value for tangent. All right, so now we do the other 3. Oops, cosecant is the reciprocal, so 2 over root 2. But we always rationalize, so we're going to multiply top and bottom by root 2. So this is 2 root 2, and then this ends up just being 2. And the 2's will cancel, leaving us with root 2. The reciprocal of cosine is secant, so I can flip this, 2 over negative root 2. Again, rationalize by multiplying top and bottom by root 2. So I have 2 root 2 over negative 2, and the 2's cancel, leaving me with a negative root 2. And finally, cotangent. Cotangent is the reciprocal of negative 1. The reciprocal of negative 1 is still negative 1. So those would be the 6 trig functions that you are looking for here. All right, very last question is number 17. Number 17 says find the exact values. So we do that sort of unit circle idea. So first we want to find the sine of 570 degrees. I told you guys first to figure out where 575 or 570 degrees is on the circle. So we know we go around a full lap. So let's see how many that leaves us with. So if we do 570 minus 360, we can find the angle that's coterminal with that, and that would be 210. So we go around, keep on going, and then 210 lands us about right here. So that is 570. All right, so what we want to do is recreate just like one little slice of the unit circle here. Okay, so figure out what that ordered pair would be. Remember, it's going to be negative something over 2, negative something over 2, because I'm in the third quadrant, so they're both going to be negative. All of them are over 2, except for these 4 main ones on the ends. And so let's recreate our pattern. Remember, our pattern starts at this line right here and works back towards the x-axis, and the pattern goes 1, 2, 3, 1, 2, 3, and then you can put them under square roots. Okay, there's no point in taking the square root of the 1 because it would still be 1, but you could if you wanted to. So sine is always the y value. So that means the sine of 570 degrees is negative 1/2. So that would be your answer. And you do that, like I said, just by creating a little piece of the unit circle. So that was part A. And last one, part B. Cosine of 11 pi over 6. Okay, so I know a lot of you are still a little bit shaky on the radian measurements. So if you don't know what they are, do that thing from earlier in the chapter where we convert. So we convert back and forth by multiplying by 180 over pi. So to get into degrees where you're more comfortable, you can always feel free to do this. And then 180 divided by 6 leaves you with 30. 11 times 30 is 330 degrees. So if we wanted to sketch this, it's in the same spot as 330 degrees. So that would be like right here. So all the way around, and it lands you right there. So we are trying to create one little piece of our unit circle. We're in the fourth quadrant, so it's a positive value of x and a negative value of y, but we know they're all over 2. And the way the pattern goes, we start from this line, the y-axis, and work our way back to the x-axis. So the pattern goes 1, 2, 3, 1, 2, 3, and then put anything that's not 1 under a square root. Okay, so that little value looks like that, and cosine is always the x value. So our answer is root 3 over 2. All right, that's the entire practice test, you guys. I hope this is helpful.